Physics in parkour. This is the Kong vault. The Kong vault or the cat pass is a way of jumping over objects taller than the height you can actually jump to. What it does is it uses your body's momentum to propel you forward while using your hands to add a substantial height to your jump. When you run toward an object like a wall, you jump just before it, put your hands on the wall and get your legs closer to you, and then you get your entire body through the space between your legs as is illustrated in the video. When this is done perfectly, you can jump to greater height and traverse higher objects even at a substantial velocity. Physics behind parkour. This is the precision jump. The precision jump is an astonishing feat if you really think about it. Basically, it requires the person to decide how much force he actually needs to apply to land on a particular spot. As seen in the video, even a small amount of misjudgment can cause a potential loss of balance and failure. The average force to be applied on the ground or any other surface you're jumping off of, taking into account the acceleration due to gravity for an average human, is around 70 newtons. This is the precision jump. Parkour. The roll. Every time that jump is made, as you notice, the body assumes a sort of Z shape. This is automatic and comes naturally to a person, but the physics behind it is that it creates a suspension-like effect, which reduces impact on the balls of the feet, which if it doesn't would break your feet, like literally break your feet. It spreads the force of impact over a larger area. The roll after is done in case the height of the jump is too high, and it further spreads the force of impact by change of direction of motion and increasing the surface area, which is the part where you roll on your back, basically. Physics in parkour. This is tic-tac. Tic-tac is when Newton's third law is applied. Essentially, you run towards a wall, jump, and at the same time land on its surface with one leg. And because of the momentum you provide, the wall provides a normal force, and use this normal force to go to a greater height because you've already jumped, and hold on to something as shown in the video, or to climb up a taller structure. If the object is not parallel to the wall or surface but is in a different direction, you do the same thing but at an angle so as to adjust your trajectory, and so that the release of the jump is also the same angle but on the other side of the normal, making it possible for you to get on or hold on to those kinds of objects as well.